All right, the nose is part of the conducting zone or conducting division of your respiratory tract. And with respect to the respiratory system, its job is to warm, moisten, and filter air. It also plays a sensory role as well. That's not really a respiratory role, and its sensory role, of course, is to detect smells or odors. Another function it has is the walls of your nose act as like a place to bounce sound around, and they help. It helps to amplify your voice. If you've ever had a really stuffed up nose, you'll note that your voice changes. It gets more kind of whiny and nasal sounding because sound is not able to bounce around in your nasal cavity. But with respect to the respiratory system, the primary function of the nose is to warm, moisten, and filter the air. It's able to do that thanks to nasal conchae, also called turbinate bones. The nasal conchae are three pairs of bony projections that stick out into the nasal cavity, and they increase the surface area of the nasal cavity, and they cause barriers for air, and so air coming into the nose gets slowed down as it slams into and swirls around those conchae. And that increased surface area and slowing down of air gives us more opportunities to warm, moisten, and filter the air before it can get down into our lungs. Each of the conchae are covered in mucous membranes. In fact, the entire lining of your nasal cavity is covered in mucus, snot in other words. And an important function of that mucus is to trap pathogens that could potentially be entering the body through the nose. Another thing that you find inside the nasal cavity is underneath each concha, or conchae, which is plural, you find kind of narrow canals or tunnels. And that, again, is going to cause the air to slow down as it swirls around through those tunnels, creating turbulence. And that ensures that the air is going to contact the mucous membranes on the walls of the nasal cavity, again, so we have more time to warm, moisten, and filter that air. All right, looking closely at the nasal mucosa itself, it's that mucous membrane lining of the nasal cavity. You've got two types of mucosa, olfactory mucosa and respiratory mucosa. The olfactory mucosa plays a sensory role. It's on the roof of the nasal cavity, and it's embedded with olfactory neurons, with receptors, dendrites, to detect odors, detect volatile chemicals, gaseous chemicals. So that's more of a sensory function, nervous system function, in other words. The respiratory mucosa is the mucus that lines the rest of the nasal cavity, and it's important for defense against pathogens. So within the respiratory mucosa, you've got goblet cells, which are just cells kind of shaped like goblets, shaped like a basin or a glass, and they hold a bunch of mucus and release that mucus onto the surface. And the mucus can then trap any inhaled debris or pathogens that might come into your body. Now, you got to do something with that mucus, and unless you have a terribly runny nose, the mucus is not coming out the front. It is going to be pushed by cilia back towards the throat, and eventually you swallow that mucus down into your stomach, and ultimately it can exit through feces. And another function of that mucus, aside from trapping pathogens, is it does help to humidify the incoming air. The mucus has got a lot of moisture, water in it, so it helps to humidify the air before that air can go down into your lungs. Another thing you find in the nasal mucosa is an enzyme called lysozyme, which is antimicrobial, and it can destroy certain types of bacterial cells. So again, that's a defense mechanism. And another thing that's certainly true of the nasal respiratory mucosa is it's highly vascular. It's got a large blood supply, which ensures that there's a large supply of white blood cells can make it to the area, again, to help us with defense. The fact that there's a lot of blood flowing through the walls of the nasal cavity, too, means that that blood will warm the air as it comes into the body. Now, if you've ever had damage to the nose, you know how quickly it can bleed, and that's thanks to that large blood supply. So if you take a hit to the nose, it bleeds very readily because of all that vascular tissue.